Hey everybody, here we are in our size of scale factors assignment. Our learning targets are to describe the effect on a scaled copy when you have a scale factor that is greater than 1, less than 1, or equal to 1. We're also going to look at what happens when we take a scale factor from one figure to another and then back the opposite direction. So I'm going to show you a couple of examples. I just want to remind you that factor refers to multiplication always. To use a scale factor, we take a given dimension from a diagram and we multiply it by the scale factor to create the new desired measurement. All right, here is an example with some rectangles. Here's a rectangle that's 3 measurement units in one direction and 2 units in the other direction. The scale factor is currently set at 1. 1 times 1 is 3. 1 times 3 is 3. 1 times 2 is 2. So the new diagram and the old are exactly the same. But if I increase the scale factor to 2, you can see that my new red rectangle is twice the size. 3 times 2 is 6. 2 times a scale factor of 2 makes a distance of 4. So this new rectangle is twice the length and twice the height of the original. If I set my scale factor to 3, you can see that the length is now 3 times 3, or 9, and the height is 2 times 3, or 6. So if I use a scale factor that's larger than 1, this new red rectangle is becoming larger than the original blue rectangle. If I set the scale factor equal to 1, you can see that the new and the original are exactly the same. If I set the scale factor less than 1, I'm reducing the lengths of all of the rectangle measurements, all of the dimensions. So if I say take 1/2 of 3, I get 1.5. I take 1/2 of 2, I get 1. The dimensions of this smaller rectangle are exactly 1/2 the size of the original rectangle. When we look at scale diagrams, here is an original letter F. Drawing number 1 right next to it is a scaled diagram. It's a copy where every length has been multiplied by 1.5. So here's a length of 1, 2, 3, 4 for the height of the letter F. I multiply 4 times 1.5, and that makes 6. So this new height should be 6 units tall. 1, 2, 3, 4, 5, 6, and it checks out. This top line of length of 2 becomes a top line of a length of 3, because 2 times 1.5 is equal to 3. Here's that's all I wanted to say about that page. So now if I take you to the bottom of the bottom of this page, you will see an interesting diagram where the numbers aren't quite as easy to work with. But here's what happens when we go from one diagram to another and then back again. Here's a smaller triangle. I'm multiplying it times a scale factor of 1.5, or 3/2, to get this larger version. So 5 times 3/2 is 7.5. 3 times 3/2 is 9/2, or 4.5. This length of 4 times 3/2 is 12/2, otherwise known as 6. If I want to go from the big triangle back to the smaller one, you'll notice the scale factor has been flipped. We call this the reciprocal. It's down here. The reciprocal of 3/2 is 2/3. If I start with 6 and multiply by 2/3, I get 12/3. 12/3 simplifies to 4. If I multiply 4.5 times 2/3, I get 9/3. 9/3 simplifies to 3. If I take 7.5 and I multiply by 2/3, I get 15/3. 15/3 simplifies to the number 5. So here we have an increase because we're multiplying by a scale factor bigger than 1. We get a slightly larger rectangle. It's 1.5 times the length and width of the original. Oh, this is triangle, sorry. And if we take our large triangle and try to downsize it, we use a scale factor less than 1, and we create a smaller version.